Thank you, thank you. So this talk is about Fable is a lot of things, and I will talk about all the things it can do. But this talk will mostly be focused on the Python part, which I have been contributing to for the last years. A little bit about myself. So I would say that I like to present myself as a Python programmer in love with F#. Work at Cognite, previously at Microsoft. Now I live in Oslo. And my sort of history with programming language has been that I learned my C programming, then it was Python, then it was JavaScript, then it was Python, then it was C#, then it was Python, then it was F#, then it was Python, 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 F#, Python, Python, Python. So I never get rid of Python. It sort of haunts me. Whatever I do, I always come back to Python somehow. So that's why I started trying to see how I could combine F# and Python. But let's talk about F# for those who are not that familiar with it. It's a functional first programming language for .NET, statically typed, but what I like to say is that it has this dynamic feel. And for those who are familiar with Python, it feels like Python. In some sense, yeah. It has, but it's really sort of robust, mature, and fast. So when you run F#, it's sort of typically like 100 times faster than Python. And it's super stable. When you open an F# program 2 years later, it still works, which is not you. I cannot say the same thing about Python. It has great tooling, Rider, VS Code, Visual Studio. And F# with this superior type system, type inference combined with pipelining, pattern matching, computational expression, makes F# a better Python. That's a statement I want to say. And if we look at what is Fable, so Fable is a compiler or a transpiler, as we like to call it, that translates F# code to JavaScript, TypeScript, Python, and Rust. And we say it transpiles because it translates code from the same level to another language on the same level. So when you compile, you usually compile to something more low level, like bytecode or assembly or to machine code. But when you transpile, you translate from one language to another language on sort of the same level of abstraction. And the idea when you have Fable, that when you can translate to other kind of languages like this, is that you can write some library once, and then you can compile it into something that can be used on many different runtimes and platforms. So suddenly you have one library, you can use it in your JavaScript program or application. You can use it on .NET on the server side. You can use it in Python for some data science. So you have the same library. It might not be easy to find what that library should do, but once you have something like that, you can finally have this write once, run everywhere. Yeah, so interaction with other ecosystem communities. So Fable makes it possible for F# developers to explore other worlds beyond .NET. And the current status is that when you compile to or transpile to JavaScript, it's stable, TypeScript is stable, Python and Dart is considered beta, Rust is alpha. Even if I checked the last time, that Rust is now has almost 2,000 passing unit tests. So it's getting quite mature, I would say. It has more unit tests than Python and Dart. This sort of tells what the state of those languages are. So how does it work? We take the F# source code, we make it into the F# AST. And what is an AST? And I can show you what an AST looks like. This is a short F# program. And when you translate it into an AST, which is the abstract syntax tree of that, then you get a data structure that represents this code, piece of code. And we see that it's quite verbose. So we take the source code, make it into the F# AST, and then we translate it into what we call the Fable AST, which is more suited for translating into normal these imperative programming languages like JavaScript, Python, and others. So the F# AST is only expression-based, while the the Fable AST is more statement-based. So it's easier to make sort of normal for loops and if tests and function declarations and all of that. So we take the Fable AST and then we can translate it into the Python AST. So we can look at how does the Python AST look like. So here's a web page that tells you that Python has modules, statements, expressions. So Fable translates F# eventually into this, and then we can print it. And when we print it, we have a Python program. So that's so a little bit about Python if you don't know. Easy to use. It's I would say the most popular programming language in the world. It has super low friction, so it's really easy to get started. And that makes it a popular choice for new developers. It is sort of the de facto language for data science with all these popular libraries like Pandas, NumPy, SciPy. And what you will say is that Python is the second greatest programming language for everything. So whatever programming language you want to use, then Python is your second choice. But why do you not want to use Python? And the one thing is that it's super slow. It's like 100 times slower than. So we had this ray tracer in Fable that Encave implemented, and it translated it into Rust, rendered a scene in 1 second. We did the same thing with F#, 1.2 seconds to render the same scene. JavaScript, 3 seconds. I was super impressed. Then I took Python, and I expected, my brain said, this will take 10 seconds. I expected 10 seconds for JavaScript. It was 3 seconds. So I ran it, and I thought something was wrong, but then eventually after 100 seconds, Python was done. So Python is super slow, but you are going to learn that it doesn't matter, because I can write my Python extensions in Rust and import them in Python. And then suddenly my Python is faster than your F#. So that is one of the goals sort of that I have for Christmas, to be able to sit down and make Python extensions in Rust. I write the same F# code, and then I say this file will be an extension code, extension module for that I've compiled to Rust. The other one will be Python, and then I import the Rust part into Python, and then suddenly my Python is super quick. But the dynamic nature of Python makes it hard to refactor code, among other things. And you can add type hints, but type hints are sort of ugly. They break your code with every new release of the static type checkers that you can use. So I have one library called expression where I sort of re-implemented all the nice things from many nice stuff from F#. And even now, after 2 years, I bumped the static type checker 2 versions, and I got 42 errors. And half of them are false positive, half are false negative, and I have no clue what to do. And it takes me like 2 days to fix this, and I have to do that every time. And it never gets better. So eventually you spend all your time fixing typing issues. Or you just never look at that code again, because, yeah. But then the question is, so why use Python at all? And the reason is you need to interop with Python ecosystem. You have dependencies, and dependencies. So you have some libraries you have to use, like some ML libraries, or you want to use pandas or NumPy or some of these really good libraries. And then you don't really have a lot of choice. And maybe you actually want someone to use your code. And then it's quite good if you can publish it as a Python package, especially if you're in like the machine learning community. So I started writing Fable for Python. It produces sort of code that runs sort of nicely with 3.9 to 3.12. Tries to conform with the style guides. It includes type hints. And I would say it's probably better writing Python code with type hints than you are. and this is because F# is super good at typing. So when the Python static type checker says, no, your code is wrong, then I know, no, you are wrong. Yeah. So usually I don't want to complain to them. I think that a few months later, they have probably figured it out, and my code will type check again. It has async and task support. Async compiles to F# async. Task compiles to Python async await. And last night, I fixed the F# async, so it eventually runs on the async IO main loop. So now they are compatible with each other, which means that my F# async compiled to Python is just F# semantics on top of async IO. So you get the laziness and the composability that you love to use. Sort of similar to what you would get with in .NET. And we have some nice libraries now that have been made for Fable Python. Some of these are the super FS Toolkit error handling. It works with every. It works on .NET. It works on JavaScript. It works on Python. Async RX, which I wrote many years ago. It also runs in the browser. It runs on Python. It runs on .NET. And then I side made Fable Simple JSON, Fable Request. I took the Giraffe web server and ported it to Fable. And I will make a demo of that afterwards. And this one I haven't seen before, and it was a nice surprise. Someone took the Expecto test framework and ported it so you can use it from Fable Python. So to get started with this, you can run Fable as a .NET tool. So you write this .NET tool install -G for global and Fable, and then you can run Fable, and then you can set the language to Python or JavaScript or whatever, and we will compile it like that. Yeah, this is also to install it in a project with the tool manifest. So this is, I can add the slides so you can find them afterwards if you want to see how you're doing this. Some basic functionality with, and now I'm running Fable side by side. So you can see F# code here and then see how it becomes. So we can say that this is now, if we save it, you see that it suddenly turns it into a float. Or if we say that this is, oh, that was a good, then it becomes a string. We can take this function and so you see that it compiles it to Python and adds type hints, which means that in F# this is inferred. So we can say that this is float like that, and then the Python code needs to say that this is. Or if we say that you have actually no clue about what this is, then we translate it into a generic function. So you see that Python is quite more verbose on this. It made this type parameter b that we didn't use because I don't know how to remove it afterwards, but it detects that it's not used, and then I say it doesn't matter what this type y is, so I make it into a and let's see if we do, yeah, we can return none, we can do x, let's say we do like this. So this is a special case which is sort of nasty. We have a function add like this, we don't know what it is, and I don't really know what to compile it to. So I say it's an optional A that might, if you don't send it to me, I have to say it's none, because in F# I can say add and give it unit, which is not like you think you're calling the add function. In Python programmers will think that these brackets are, or the parentheses are for calling it, but it's actually a value that you give to the function, which is why you write it like this and not like this. But for Python, I actually have to make it into a call, and then there's no argument anymore, which means that I have to say that if you call it like that, then it's actually a none. So there's some ugly parts of it. And we have support for options, but they are erased when you compile it. So all the options are gone in the final code. So you see that none becomes none, but some AB becomes A divided by B. And then there's a super nice feature that I made a demo last night, and it didn't work. But we can see what it. So now you see that, and it looks sort of scary. I have an add function, I return A plus B, but what happens now that we are suddenly inside Python code. It will be more apparent if I do like this. So this factorial is so what happens here is that I have this Python function that takes a string template or a string interpolated template string, and then I can suddenly write Python code inside of this bracket. So this is a string that starts here and stops here. But Alfonso made a syntax highlighter for it. So it recognizes that inside this string there's Python code. So let's syntax highlight it. But this means that I can now look inside the string and see that it takes account that is an integer. And that also means that if I didn't know how to write this factorial myself, I could actually import it from the Python standard library or the math library, like that. So this makes it super nice to interrupt with Python, instead of making these bindings that can sort of be a black art for those of you who have done it. Yeah. And there's if we look at more complex code, this is sort of more like I have this code that is using continuations. That is sort of what I started with to test that the transpiler was actually working. So we can see what it looks like if I. So nested functions. And then you see it becomes pretty much the same thing, actually. So I would say that Python looks quite similar to F# or vice versa. There's not much. The super hard thing with Python is that I could say here that I have a let y or a mutable y equals 0. And then I can inside here say that y is, yeah, like that. And now it becomes super hard in Python, because in Python I don't know if this is this y, is it, where is it declared and where is it modified, because it looks the same. You say y equals 1 and y equals 0 up here. It's sort of the same thing. So in Python you have to look through all the scopes and know that this y is not declared here. So I say y equals 1, but this is not the declaration of y. I have to say that it's non-local, it's declared somewhere else outside there. And I have to keep track of all the scopes and where it lives. So that is sort of some of the challenges of transpiling F# to Python. And then we could say that xs equals, yeah, it guessed we wanted a list. But then you see it becomes an F# list. It's not a Python list, because F# has an immutable list. And we can actually see how that code looks like. So this is F#. The code for the F# list has been transpiled to Python. So we have the implementation of that, if anyone wants to look at it. So it's super long. Yeah. But that's how a list, F# list is implemented in Fable Python. It's written as F# transpiled to Python, and then we run the Python code of it. But we could say that y, and then we could say that this is an array. Like that. And then it actually becomes an array, yes. A proper Python array. But if we say that it's, let's say it's a resize array, then it becomes a Python list. So you sort of have to know how this, yeah. Okay, let's go back. That one. And then I have a demo of the time flies, or a time flies demo of the async RX library. And this was inspired by the async observable that is part of the reactive .NET Reactive project implemented by Bart Smet. Let me see. time flies. We can probably show the code of that one. Yeah, so this is the code of it. It has a lot of these flat maps, and so it takes a stream of mouse moves and transforms it into stream of characters, and then it takes every character, made it into a separate stream, and then it takes every character stream and delays it by the index of the character in the word we are looking at. So to show how it will be, then we can run it like that. So we have this. There's something with my new OS X that makes it a little bit sluggish, but so that means that we can actually look at how this is the code from that library written in F#, and we can actually look what does the equivalent Python code look like, and it's quite complex. So you don't want to read this, but it works perfectly, which is sort of surprising. It has some type errors, but eventually the static, no, the line too long. That's fine. We can live with that. But mostly it type checks. And this one also shows how you can integrate with tkinter to use a UI library. And I'm quite fond of this same mailbox process that Bjørn Einar mentioned, because that makes it possible for me to write lock-free code, which transpiles just as easy to JavaScript as Python, without me having to wonder how do I do proper locking in different languages. So then someone wants to ask why can we do something useful here? And the answer might be no. But then I thought I will make something productive. Let's say you have something, you want to use a Python library and you also want to use it backend with some web service. Then it's sort of not that easy to use it from the normal Giraffe web server that you run on .NET. Then you have to call out to Python in some strange way. So what I did was to re-implement Giraffe. Let's see if my wants to. Okay. So this is the web server. It sort of looks quite normal. You have the web app, the choose function from Giraffe. Then you can actually set up an API with Fable remoting. You can set up routes, HTTP handlers, and yeah. And then this looks quite normal as you would do it in .NET. Other than use struct_log, which is a logging library for Python. So we can say .NET run app like that. And then we will transpile all of the code to Python, and we will run it like you see here with Uvicorn, which is the low-level Python web or TCP handler. So then we can check localhost 8080 not found, but I think I have it on ping. Then it says pong back. Like that, yeah. Let's. This is quite good at handling requests. And we can always say that this is not too good. Let's see. Go to app. Let's put up yeah, like 15 workers. Now it becomes quite fast at handling like 1400 requests per second. As a Python server, that is good. I know you're not impressed, but yeah. But the sort of the holy grail of F# development is when you can use safe stack, which means that you can write your web application in F#, both client side and server side. Which means that you can share your data model between the client and the server. It's written in the same code, same file. You just use that same model for both. And we can look at let's see, we are in, stop that one. Yeah. So this is a safe stack program. And this is sort of this is the holy or the most beautiful place you can be when you love package managers, because you will have one for .NET F#, you will have one for JavaScript, you will have Poetry for Python, all of them in the same project. So then you can use Poetry, you can use NPM or Yarn, and you can use Paket or NuGet. So this is the server code. And you have the client code, which is also written in F#. And then you have the model, which is shared between the two. So you have the same code that is now transpiled to both client and server. You can start this, and then there will be a lot of gears turning to get all of this. You see NPM is running, compiling both the server and the client. Total time, 11 milliseconds. Okay, I'm not sure I believe that, but we can. Okay. Oh, where is it? Oh, it's not finished yet. Start a Fable compilation. Of course, if you were in a production environment, it would all be pre-compiled. So then it's not a problem. But now we are sort of in a development environment, so we compile it again. Now we have the safe demo, which is a to-do list. So now we can write F# Oslo, and we can add it to the list, and we can see that that this is sent to the web server. So if we do a full reload of this single page application, then we see that F# Oslo is still there because the server still has the state for us. And we can see that it actually requested that state from the server. So it did an API I-to-dos, get-to-dos, to get the to-dos list back. So that we know it works. So that means that we have our one F# application. It's in the same project. Half of it is transpiled to JavaScript that runs client side. The other half is compiled to Python. In this case, we can choose Python or .NET if you want to have it run quick or slow, or depending on the dependencies you have. Do you need to have NumPy as a server dependency or not? You can choose if you want to use one or the other. And later, I will, next time, I will take half of the server implementation and compile it to Rust instead, and then it will be faster than F# again. So that's the dream for a project like this. How are we with time? Yeah, close to then. So what's next? I've sort of been away from this project for half a year because of many things. But eventually I came back, and the first thing I discovered, I have to show you, was that my demos didn't work because a good developer like Maxime, the Frenchman that you might know about, he looked at this feature that we had made, and he said, "This is not documented. There's no unit test. I'll just remove it." So he removed it. So early this morning, I had to add back. I had to make a pull request to add back the code he removed, so that I could do this demo today. Yeah. But the idea is to be able to use more of the F# code from Python. So you could write some complex business logic using discriminated unions, and have your domain model, and then be able to use that from a Python program. I think would be useful. So not everything has to be F#. At least when you work in a company like I do, I cannot do that. But I can always make some library and transpile it to some library that I could import into a Python project. What I mentioned earlier, extension modules in Rust or Go. So I started a port of to try to transpile F# to Go, mostly because I'm sort of I don't like languages where I have to deal with memory. But Rust is so mature now with the Rust port of Fable, so I might go back to that again. And the other thing is that you can now use Python in the browser. So I wanted to make a demo of that, but I didn't have time. But this one shows that today you can say Pioneer run Python async, and it runs Python code in the browser, which means that you can now use Fable Python. I can do my safe stack, and I can transpile the client side to Python that runs in Pioneer in WebAssembly. And then I can the server running Python on Uvicorn. Then you would ask why? But it will be fun, I'm pretty sure. Yeah. So Fable is really nice. Learning F# will make you a better programmer. That's my. If you haven't looked at F#, it will make you a much better Python programmer, but it will make you a better sort of any kind of language program. So here are the links to Fable, GitHub repository for Fable, and Fable Python, the bindings for using Python standard library in Fable. Yeah, so that was my talk.